Okay, number 18. Okay, so we have a dr over dt equals negative 0.35 r. So then we change accordingly, dr over r equals negative 0.35 dt. And now we're ready to integrate. So this is natural log of the absolute value of r, and this is negative 0.35 t plus a constant c. And we are not given any constant. Okay, perfect. So remember what we did last time. So r equals e to this number multiplied by e to c, which can be replaced by c1. So then r equals plus or minus c1 e to negative 0.35 t. And that is it. That's all we need to do. As I mentioned a minute ago, I did not get the chance to post the solutions, but yes, I scanned the pages and I will. If you have any questions for the previous homework that was due last Thursday. Good. Anything else?
We also go on that same.
I couldn't hear you. Which one?
Number 24 on the same page.
Yes, number 24. Number 24 is f prime of x equals x to 2/5 plus x, and we are given f of 1 equals negative 7. Basically, this is actually chapter 4, but they're also here. So then f of x equals x to 2/5 plus 1, which is 7/5 over 7/5 plus x squared over 2 plus a constant c. I have to flip the denominator. So then f of x equals 5 over 7 x to 7 over 5 plus x squared over 2 plus a constant c. But we have the initial condition. When the function is negative 7, the x is 1. So 5 over 7 plus 1/2 plus c. I move everything to the other side to find c as negative 7 minus 5 over 7 minus 1/2. The least common denominator is 14, of course. So we multiply 7 by 14, and this is by 2, and this is by 7. And everything is negative, so I'm going to put the minus in front, and now everything is positive at the top. So 98 plus 10 and plus 7. So then the constant is 108, 115. Am I correct? So then the function becomes 5/7 x to 7/5 plus x squared over 2 minus 115 over 14. Any questions? Anything else? Is there anything else that we want to look at? Anything else before we move on to 6.2? You can always stop me, of course. Anything else? Okay, I want to open the book in the background. And let's talk about, this was my page 2. And let's continue with 6.2. In 6.2, we are going to talk about something called partial derivatives. So if you remember when we differentiated, let's say, a very simple function, x squared plus e to the x, we used several notations, but one of them was dy over dx, which is 2x plus e to the x. Of course, it's the same with f prime, all the same. But notice one thing here. This notation is very important and it tells us a lot. So I'm just opening the page at 6.2. Okay. So what does this notation say? Yes, this is a differential of y and this is a differential of x, and we know they also have other meanings. But this notation, first of all, says y is a function of x. This notation also says that y has only one variable, which is x. Now, when we look at, for example, f of x comma y, this function has two variables. And I'm just going to make one function up, and then we look at examples we choose. So x squared y to the third plus y squared. That's an example. Well, we can never differentiate at the same time with respect to x and with respect to y. That's not possible. That's why all we can do is find partial derivatives. If we differentiate with respect to x, it means that y is fixed. It's like a constant. If we differentiate with respect to y, it means that x is fixed, like a constant. We can no longer use this notation, regular d, the derivative of y with respect to x. No. So let's say we want to differentiate with respect to x. This is the notation. The partial derivative of f with respect to x. This notation says f has more than one variable, is a function of more than one variable. And this also means f is differentiated with respect to x. Everything else is fixed. All other variables are fixed, meaning they have to be treated like they are constants. Okay. Of course, we have df over dy. We prefer a different notation because this is kind of cumbersome. We prefer this. This is not in parentheses. This is not f of x. This is read fx. This is read fy. What does fx mean? It means differentiate function f with respect to x only. What does fy mean? Differentiate f with respect to y only. What about fxx? I differentiate f with respect to x, and then again, this is the second derivative, the second partial derivative. Can I find fyy? Yes. Can I find fxy? Yes. What does this mean? I differentiate the function f with respect to x, and then when I'm done, I differentiate with respect to y. Okay, also fyx. What does this mean? It's the partial derivative, the second order. I differentiate with respect to y, and then I differentiate with respect to x. So we do not have to use this notation, but I want you to understand what it means, because we prefer this one. It's easier to write, easier to even to say, right, to read. So we don't prefer this, we prefer this, but they mean the same thing. So coming back here, I would like us to go through all the derivatives. Fx, fy, fxx, fyy, fxy and fyx, just for this simple function, and then we'll do the same thing, but we'll choose problems from the book. I open the book so we have it in the background. Okay, so I'm coming back to fxy, x squared y cubed plus y squared. Okay, so we want to find fx, fy, fxx, fyy, fxy, and fyx. Okay, just I want to open on page 567. Okay. Good. So we can choose the next example. Good. So I'm differentiating this function with respect to x, meaning y is fixed. When I differentiate x squared, I get 2x times y cubed. I do not treat this as a product. This is a constant because I can only differentiate with respect to one variable at a time. And this is a constant prime, which is 0. Now I differentiate with respect to y. 3x squared, y squared. This is a constant. I'm only differentiating y cubed. So this is 3x squared, 3y squared plus 2y. Now I go back to fx and I differentiate it again with respect to x. So the answer is 2y cubed because these are constants. When I differentiate x, I get x prime is 1. So the answer is 2y cubed. I go back to fy to differentiate again with respect to y. When I differentiate this with respect to y, I get 6x squared y. When I differentiate this with respect to y, I get positive 2. I go back to fx and I differentiate with respect to y. So I get 6xy squared. I go back to y and I differentiate with respect to x, and you'll see something very interesting. Okay, so I'm here and I differentiate with respect to x. 6xy squared. I differentiate with respect to x, there is no x. fxy and fyx are the same. That's all about differentiating functions of multiple variables. Okay, so we are ready. So you see the symbols, fx, fy, fx evaluated at this, fy evaluated at this. Find fx and find fy for these problems. Then find the partial derivative of f with respect to b. Find the partial derivative of f with respect to m. This would have been fb and fm, and so on and so forth. And then here they want us all, because I can never differentiate or find fxx if I don't find fx. So here we're asked to determine everything. fx, fy, fxx, fxy, fyx, and fyy. Okay, so let's choose. Anyone? Yes?
9.
We want to start with 9. Very good. Excellent. So let's start with 9, which is f of xy. So it's 9 on page 567. And it's e to 2x minus y. Perfect. Good. So we're asked to find everything. fxx. Well, actually, let's take a look. For this set, they only want fx and fy. So we're going to stick with that. Good. So fx means I differentiate this with respect to x. E to a function prime is e to that function times the function prime, which is 2. Because I only differentiate with respect to x. Everything else is considered a constant. Now fy e to a function prime is e to the function times the inner function prime, which is -1. Because when I differentiate with y, x is a constant. Any questions? Okay, let's continue. Anything else?
I don't mean to go backwards, but can we do question 8?
We can go to any problem. Anything you want. Okay, very good. So let's look at problem 8. In problem 8, we want to determine fx, fy, and evaluate fx at a given point and fy at another point. Perfect. So fx comma y is the square root of x squared plus y squared, and they also want fx at -2 comma 1 and fy at -3, -2. Perfect. Good pick. Good. So let's find fx and then evaluate it, and then find fy and evaluate it. When we find fx, we differentiate with respect to x only and keep y fixed. So fx will be the square root prime, 1/2 the square root of x squared plus y squared, times the inner function prime only with respect to x. I simplify, so I get x over the square root of x squared plus y squared. I'm asked to evaluate this at -2, 1. No problem. So fx at -2, 1 will be -2 over the square root of 4 plus 1, the square root of 5. I can rationalize. So then this will be -2 the square root of 5 over 5. The answer will be identical for fy, only that I have 2y at the top. So we have y divided by the square root of x squared plus y squared, and we plug in -3, -2. -2 over 9 plus 4. 9 plus 4, 13. The square root of 13, the square root of 13. So -2, the square root of 13 over 13. Very good. It was a nice example. Good. Next problem.